Hello, let's do the New York Times Hard Sudoku for September 6th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. 1 and 2, we're looking for buddies here, so we have two 1s here. Puts a 1 in one of these two, and two 2s here, puts a 2 right there. All right. 9 is looking into this box, and it's not in any of these cells because they're filled. So 9 joins the 1. Now we could just corner both of them. The 1 meaning that 1 is limited to these two cells in the box, and the 9 meaning that 9 is limited to the same two cells in the box. Well, if 1 needs to be in one of these cells and 9 needs to be in the other one, what we found is a hidden pair. So overlapping corner marks like this, we can convert those to center marks, only if it's n digits in n cells and no others. So that's a 1-9 hidden pair, and that leaves a pair here as well, the just the remaining digits, which are 3, 6. This 6 tells us the order. That's 3, that's 6. Rest of this row, we have 1, 2, 3. We do need a 4, and we need a 7. Unfortunately, I don't see a way to resolve that. Oops. If we type 1, maybe we can resolve it, but no. 4, 7. Okay. Now I'm looking for things looking up into these kind of bays here that aren't 4 or 7, or 1, 2, 5, 9. So the 3, for example, is looking up, putting 3 in one of these two, and that's going to point down along with this 3, putting a 3 in one of these two. And then we also have the 2, the 6. Okay, so the 6 looks up. The 6 is in one of these two. That's going to point down along with this 6, putting a 6 in one of these. Oh, actually, no, these two 6s help. So actually what we've got here is these pointing 6s tell us that 6 is placed right there. Very nice. All right. So we get the 2, the 6, the 3, the 4 is looking up here, but we can put a 4 here. But what we can do is we can use these 4s and say 4 is in one of these two, which is still a marking. And then the 7 looks up here, but 7 can go here as well. But we do have this 7 helping, so we can put 7 in one of these two. Kind of interesting. So what haven't we marked? 1, 2, 3, 4, 5, 6, 7. We haven't marked the 8. So all of these digits are just their corner mark plus 8, because every other digit is corner marked in the box. Notice how we have 1, or given 1, 2, 3 is corner marked, 4 is corner marked, 5, 6 is corner marked, 7 is corner marked, and 9. So this is, for example, 3, 8. This is 3, 4, 8. This is 6, 8. This is 6, 7, 8. All right, we're going to keep the corner marks as well. Anything to do in this box here? Unfortunately, there's nothing down here to like look in at the important bits. All right. I think I'm going to move on to the next band at this point. So we do have 3 and 6 here. So the 6s are done. The 3, not really anything additional to mark there. I noticed this 4 looks through. Unfortunately, oh, I guess we also have this 4. Ooh, so it's not unfortunate. This 4 saved the day. All right, these 4s look in, this 4 looks in. So we can place this 4. Now these two 4s look into this box, putting a 4 in one of these two cells. All right, 3, 4, 6. I am noticing we need a 3 in this column. Notice how it can't go here because of this 3, and we also have this 3. So I guess really it's just these 3s looking down. Sometimes you'll see something through geometry that would have been a bit easier to see just through normal scanning, but you know, whatever you see first is what you saw first, right? Doesn't really matter how you saw it. Looking for things in multiple ways just increases your chance of not missing it. Decreases your chance of missing it is probably a better way to put that. All right, do I have any buddies? 3, 6, 5, 8. I really just don't. Yeah, I'm not really seeing much to do here. I think I'm going to move on. Does the 8 help? No. Okay, yeah, we're going to move on. We have this 4, we have 8, 9. So the 8 has buddies. This 8 looks down. That lets us place this 8. These two 8s look in. This 8 looks in, putting an 8 in one of these two. All right, I'm looking for geometry here. So 7 or 3 looking down. There are no 7s or 3s here to help. What about this? We have 2, 3, 6, 8. So we do need 2, 3, and 6 somewhere along here, but the chances that that's helpful is very low. Yeah, it's not helpful. I am noticing we have this 2, 6 looking here, and this 2, 6 looking here. Ooh, yeah, if we had a 2, 6 here, that would actually make a hidden pair, but, or just a 2 in this column, if we had that, that would make a hidden pair. I'll try to remember that if we ever get a 2 up here. It's quite possible that the 2 is right there, though, and in which case we don't have the hidden pair. All right, there are 4 digits left in this row. We need 1, 2, 5, 7. 1, 2, 5, 7. This can't be 1 or 2, so this is 5, 7 only. This can't be 1, this is 2, 5, 7. This can't be 7, this is 1, 2, 5. All right, not super exciting. Okay, I really think that's all we get here. Let's do the stacks. So let's start with 4, 6, 7. So we do have the 6s, but they're marked already. 4 and 7 do not have buddies. Yeah, and unfortunately that's because of this guy here. All right, we've got 2, 3, and 8. Okay, we do have these two 2s. That does put a 2 here. 3, we got the 3s. The 8 really didn't do anything. Still doesn't do anything. Okay, I think that's it for that stack. Anything reduced to 4 or fewer? No. I'm looking to see if this column might be interesting, but honestly, it's not. I mean, these can't be 7, just naturally. And this also can't be 4, so I guess we can mark this one up. So it can't be 1, 2, it could be 3, can't be 4, could be 5, can't be 6, 7, 8, could be 9. That's how many expected. Okay, and this can't be 7 or 5, so it can't be 1, 2, could be 3, can't be 4, 5, 6, 7, 8, could be 9. Ooh. Yeah, I saw 5. Why was this? Oh, because the 4 and the 7 here. I see. Yeah, I was confused as to why this was 1 fewer than that, but because this sees the 4. I used this 4 here, but really I could have used this 4, and that would have told me what I needed to know. Anyway, sorry, I'm not confused anymore. This 4 looks down here. This 4 looks in. I missed this crossing. So there's a 4 in one of these two. That points in here along with this 4, putting a 4 here. Anything else cross this 8, 2? The 9, maybe? No, because we... Yeah, the 9. Sorry. I was just looking at the wrong rows there. All right, so this is a hidden 4-9 pair. It's the only place 4 and 9 can go in the box. That's quite helpful. So the 9s look in here along with this 9. Puts a 9 somewhere in here. All right, so this is going to be a triple then, because we found the 4, 9 here. So this is 1, 5, 7. And the 1 points up. Can we do anything with that? Yeah, so that does put a 1 in one of these two. All right, 1, 5, 7. I don't think there's more to find here. Let's do the next stack. See if we find anything there. 8 and 9. So we do have these two 8s looking up. This 8 helps. Puts an 8 in one of these two. You know what I missed is this 1, 9 pair. I didn't take 9 out of these. So all these 9s look up. There's a 9 in one of these two. Okay, I'm not sure that's super helpful right now, but anyway. So we got the 8, the 9. Oh, wait, hold on. Oh, no, never mind. This is fine. All right, 1 and 2. Okay, this 1 looks into this box here, puts a 1 in one of these 3. That's going to point down along with this 1, putting a 1 in one of these two. Now we have 1s lined up here. By lined up, I mean in this box, 1 has been limited to rows 8 and 9, and in this box, 1 has been limited to rows 8 and 9. So the question is, where is 1 in row 7? Because it's not in this box, and it's not in this box. So the 1 in row 7 goes exactly here. And you can see, it's definitely not where the givens are. It's not here because of this 1. It's not here because we have the pointing ones here, and it's not here because of this 1. So 1 has to be placed here, and that gives us 9 and 1 there. So that's not a 9. Okay. I think I'm going to do this stack scan in a second anyway, so we'll wait for that scan to follow up on that stuff. So let me just make sure I finished this. So I got the 1. I really do think this is done. Oh, I wanted to look at this column, though. We need a 1, 3, 4, and 7. So these can't be 1 at all. So these are 3, 4, 7. And this can't be 4, and this can't be 7. This can't be 4, so this is 1, 3, 7. Because this 4, 9 pair can't be 4. I think this can be any of 1, 3, 4, 7, though. Okay. All right, does the 3, 7 or 3, 4 do anything? Not right now. All right, let's look at this stack then. So we got 1, 4, and 8 here. So the 1s do look in here, putting a 1 in one of these two. The 4s are done. The 8s were marked. We have 3 and 6. So the 6s we have not marked yet. Puts a 6 in one of these two. So this cell must be limited because it's not 148 and it's also not 369. So it could be 2. Oh, it can't even be 2. So it can't be 1, 2, 3. Can't be 4. Wow. Okay. So I think it's a 5. Oh, it might be 5, 7. It's 5, 7. So 5, 6, 7, 8, 9. Yeah. Darn. Okay. 5, 7, 1, 5, 7. Okay. What else can I do here? I want to look at this column. It is down to 2, 5, 6. This can't be 5, 6, so that's a 2. And now this is a 5, 6 pair. And so that leaves, 5, 6 pair. Yeah, since 5 is in the 5, 6 pair, it's not here. So that's our 7. So these are not 7s. I was looking for a 2, 6 hidden. Still can't do it. Okay, in fact, one of these probably one of these is a 2. Okay, so at least we get that. So these 2s look down, this 2 looks in. That places a 2 here, which places the 3, which places the 9. Very nice. All right. 1, 3, 5, 6. This is not 1. This is 3, 5, 6. It's not 1 because the claiming ones or pointing ones. Take your pick. All right. 2, 5, 7 here. The 2 ends up in one of these 2. All right, I got a bunch of digits. Can we follow up on any of them? The 3 maybe? 3 ends up in one of these 2. 5, 6, 3, 2. All right, maybe this box has something interesting to tell us. Yeah, this pair, for example. We need a 1. What else do we need? Looks like 5, a 1, 5 pair. And so then this is a triple. We have 1, 2, 3, 4, 5, 6. We need 7, 8, 9. This can't be 7 or 8. So here's our 9, leaving a 7, 8 pair behind. Does this 9 do anything? No. Nope, it doesn't. All right. Okay, so this stack is basically done. Now, we did get some stuff up here, if I recall. Or, no, we finished the 1, 9 a while ago. This is a 3, 4, 7 triple, though. I just noticed that. So the first thing we can say about this 3, 4, 7 triple, and you know what? I went over this the other day. It might have even been yesterday, but I'm going to go over this again because I feel like this kind of triple is the one that trips most people up, both in understanding why it's a triple and also understanding the full consequence of it. So this is just another really nice example of it. So I'm going to go over it. So I'm going to keep those cells green. We're talking about the green cells here. So the first question to ask is, can digits repeat in the green cells? If digits can repeat in the green cells, we're not even going to do this logic. Just move on, right? Like if it was this cell and this cell and in this cell, right? It doesn't even remember what the digits are. The purple cells, you can repeat digits. This can be a 5 and this can be 5. So we're not even worried about it. Okay. But the green cells, you cannot repeat digits because they're all in box 2. They're all in the same box. Okay. So the next question to ask is, how many unique digits are available to fill into the green cells? And so keep in mind that we have reduced this cell to 3, 4, this cell to 3, 7, and this cell to 4, 7. In the solution, this will definitely be a 3 or 4. This will definitely be a 3 or 7. This will definitely be 4 or 7, based on all the logic we've done so far. So as a result, 3, 4, and 7 are the only digits that are going to end up in green completely. In our solution, when we look at the green cells, it's going to be a 3, a 4, and a 7. And so we need 3 digits for 3 cells, and we only have 3 digits for those 3 cells, the 3, 4, and 7. So they are going to end up in some order, 3, 4, and 7. Now, we don't know what order they're going to go in. We know a few things, like we know this one won't be the 3. We know this one won't be the 4. We know this one won't be the 7. But ultimately, that doesn't change the fact that they're going to end up having 3, 4, and 7 in them. And these cells here that I'm going to mark purple, I suppose I might as well mark those as well, just to be clear. All of these purple cells that are also in box 2, they see all of the green cells. So therefore, none of the purple cells are going to be 3, 4, or 7. And that is a naked triple. The naked triple is, I have discovered that these 3 green cells will be only 3, 4, 7, and they all share the same box. So the rest of the box, it cannot be 3, 4, 7. We can eliminate that from the rest of the box. That's the purple cells. Now, before I do that, there's another consequence, which remember when I said this one won't be 3. We already proved this one will be 3. But there will be a 3 in the green cells, which means these green purple cells that I've made here, they will have the green in them. Sorry, they will have the 3 in them, the green. Purple will have 3 in it. So we can actually mark that 3 is going to be in one of these 2 cells. If you think about it, if we were to eliminate 3, 4, 7 from all of these cells here, then we could just say it's pointing from the box, but you can also just do it straight from the triple and save yourself some time. And that means you don't necessarily have to like mark up the box to discover that, right? The logic is pretty clear. So if 3 is going to be in these purple cells as part of this triple, then 3 cannot be here. So that makes this a 1. That's a 5. That's a 7. That's a 1. That's a 4. And now our green's just going to resolve. That's 7. That's 3. And that's 4. There we go. So as you can see, we ended up with 3, 4, 7 in some order in these cells, and 3 ended up in one of these 2. All right, so now that's 8. That gives us the 8 and the 9 here. That gives us the 3, 6, and 7. That's 9 and 4. That's 3 and 5. That's 1 and 5. All right, this can't be 1 or 4. All right, we get a 2, 5 pair here. This is not a 5. This digit we can just place. It is a 7, right? We get 6 and 5 there. That's 3. These can't be 1s. So that places the 1 here and the 1 here. That's the 4. We get the 4 here. This is a digit. Definitely is. Yep, it's a 6. All right. And now we just plunk the rest of these digits. Here we need a 9. Okay. This is 2 and... wait, what did I miss? 1, 2, 2 and 8. This 8 tells us the order. That's 2. That's 8. Gives us 7 and 8 here. Up here we have 1, 2, 3, 4. We need 5 and 6, actually. This 6 tells us the order. 5 and 6. That gives us 2 and 5. This box we need 2, 3, 7, 9. So the 2 goes there. The 3 goes there. And then 9 and 7. There we go. All right. Well, I mean, I took some time to explain the triple, but I think that was definitely worthwhile. This was a really good example of that. And I think finding this triple, and more importantly, not just finding the triple, but discovering that it causes 3 to be in one of these 2, either by directly through the triple or by noticing the pointing from the box, that finished the puzzle for us. So that was very important. I don't know if there were other ways to finish, but that's how I did it. Anyway, hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.